So before we start, let me introduce to you our webpage, which is bimklue.teachable.com. So if you access to our webpage, you can see a list of Revit tutorial pre-recorded videos available for you, guiding you from basic to advanced level. Okay, so no experience required. We have electrical tutorial, cooling load analysis using Revit, okay, then swimming pool and the plumbing services, and then HVAC services, and then even architecture modeling services. Okay, so this is our students around the world. Okay, so one of the advantage of a course is if you have any questions or difficulties, you can always contact us and we will give you our best support. Okay, so let's click on one of the example of our course. So this is the course page showing you the example of our course content, and then video example, and then the list of content here, hours of content, guiding you from basic to advanced. Okay, so don't worry about the payment. If you have payment issue, we can always contact us. We can adjust on the payment term. Okay, so that's all. Hi everyone, welcome back to BIMKLUE REVIT tutorial. So in this session, we're going to model our own receptacle, which is my single socket outlets. It looks like this. Okay, so before we start, I'm going to introduce to you to our webpage here, bimklue.teachable.com. If you can access to our webpage, then you will see a list of Revit tutorials pre-recorded for you to learn by your own. So let's say I'm going to click on this HVAC tutorials here. We have electrical, cooling load analysis at the moment, and then a swimming pool and the plumbing services, and architecture step by step. And beside architecture, I'm going to teach also the twin motion. Okay, so let's pick on this HVAC system. So if you access our course page, then it will show you a list of tutorials available here, hours of tutorial, guiding you from basic to advanced level. And then this is our examples of tutorials, our example of video, and then the payment here. Of course, if you have any difficulties on the payment, we can improve our payment terms. Okay, and that's all. So without further delay, let's start our session today. So first of all, similar to the lighting switch, I'm going to start with new family again. Go to English. Also a wall-based family. Okay, not wall-based, it's a face-based. Okay, open. Then you will see a rectangle here. It represents a wall. So if you go to 3D view, it will look like this. Okay, this is a wall. So let's start to model our socket outlet here. We close the switch. And this is the socket outlet, and the dimension is 87, 87. Okay, so we have also a curve edges here, top and bottom, and then the curve corners here. Okay, and the button and the pinholes. So let's start to create an extrusion of 87 mm and 87 mm. So move it to the center. Then use a fillet arc tool. Then click on here. The radius is 3 mm. Click on here, 3 mm. And then the thickness will be 10 mm. Okay, so finish. So the 3D view looks like this. Okay, then from the left view, I'm going to create a void similar to the steps of creating the switch. I'm going to use the void tool to cut a void to form a curvy edge at the top and bottom. Okay, so move it to here, then complete the polygon, the loop. Okay, mirror it to the other side, then finish. Then from the 3D view, you can see there's a void created cutting our solid. Okay, so adjust it, then we can complete our cut. Then from the left reference level again, now we model the pinholes. Create using the void extrusion tool to model the pinholes. Okay, something like this. And mirror it to the other side. Something like this. Okay, then move it down a bit. Okay, something like this. Then finish. Then from the front view, you can see the void is cutting through the plate. Okay, that's fine. Then from the 3D view, looks like this. Okay, then from the left view again, we're going to model our button. Going to create extrusion. So this is the switch button, something like this. Finish. Then from the reference level, so move it to here. So check it out. It's something like this. Okay, similar. So from the 3D view, you can see the button is here. Maybe moving a little bit further. It's like this. Okay. Then reference level again. Don't forget to model our back box, the square back box of our wiring termination inside the wall. Okay, it's going to be 75 mm. Then move it up here, then move to the center, then 0, then this one is -35. Apply, finish. Then from a 3D view, if you turn to wireframe, it will look like this. Okay, so this is a face plate, and then at the surface of the wall, and then this is the back box. Okay, so we select everything here, then use the selection filter to avoid the selection of void. Okay, I don't want to select the void. Apply, then okay, then we assign it to material parameters, PVC white. Okay, then we just leave it at the moment. So next is the legend. Okay, the legend. I'm going to insert, load a family, go back to my folder here. I'm going to use the similar lighting switch notation. Then I go to annotate symbol, I place my legend here. Then I'm going to edit it to become my socket outlet legend. So I delete this. Going to create 1.5 mm to the left and to the right line, and then create a line here, a curve of 1 mm radius. Then mirror it to the other side. Create a line of 1 mm again. Then a line of 1 mm again to the left and to the right. So this is my legend of socket outlet. Remember to save save as family, a notation of socket outlet. Okay, save, then load it to my family instead of project. So place it over here. So that's all. Delete the switch family. Then we save. Before that, go to family category and parameters. I'm going to tell Revit that this is electrical fixture instead of generic model. Okay, so maintain the annotation orientation. Check this. So what's important of this I have explained during the last section. Okay, so click OK. Then we save as family, single socket outlet. Then load it inside to our project. Then we place on the wall. So this is my socket outlet. Okay, so one thing you need to remember that you always need to add an electrical connector for your single socket outlet. Okay, so go to electrical connector. Just place your electrical connector somewhere here. You can be any surface. Then we click on this electrical connector. Assign it to be power balance. Pole is one pole because it's single phase. So load classification, click here, it is power. Then voltage is according to your country standard. And a parent load, assign it to be 250 normally in the design. Okay. Then power factor, I'm just going to leave it at 1. Then click apply, then load it back to my project. Okay, now when you click on this socket outlet, you can see the electrical properties of this socket outlet here. It's important for you to create your circuiting later. Okay, so that's how you create your own single socket outlet. And then before that, if I'm going to click on this edit type, it's blank. Okay, it's not according to the standards of BIM. So you need to go back to the family again. Then from this family and types, you need to fill in the model, your manufacturer, type command, let it to be electrical, then URL. The URL is your web page here. So copy this thing here, paste over here, then description, single cost 30 is very subjective. Either it is only a material cost, or you need to lump in your labor cost, your warranty, your defect liability period, and then your professional fees. Okay, so it's up to you to price in here, then apply, then okay, load it back to my project. Similarly, you can also fill in your lighting switch here, or you can fill in from here, edit type, model is piano, manufacturer is Schneider, type command is electrical, URL is your this one, description is lighting, one gang, cost 25, 20. Okay, whatever. If you want to add in more details, you need to go back to your family editor to add the parameters here. Okay, so click apply, then okay. Then whenever you click this lighting switch, you already have your details over here. So once you click your URL, then you can straight away bring in to your web page here for more information. Okay, this is the this is the ultimate aim of building information modeling, where everything you model in your project will be sufficient information for you to purchase your materials in the future. Okay, so I think that's all for this session. Thanks for joining.